Okay, so I'm just going to do a quick run through of how to set up a case on Runpod. So I've logged into Runpod here. I've got just over $2 of credit. So first thing I'm going to do is to select a GPU, and one of the good ones is this A40 because it's got 48 gigabytes of virtual RAM and it's only $0.39 an hour. So I'm going to select that. I only need one of them, and so select deploy on demand. So that will just take a few seconds to load that one up. And obviously you can select any GPU you want. There's loads to choose from there, depending on how much RAM you need and how much balance you have on your account. Some of the most expensive one is about $4 an hour. So this just take a few seconds to load the pod. Okay, so when it's loaded the pod, you can see it here, and so the first thing to do is connect to it. So connect using Jupyter. Jupyter takes a few seconds to load. So when you start that, the first thing to do is to upload the files that you need. So there's the executable, there's the text input file, and there's the geometry. So I'm just going to upload those three. And while it's doing that, I can load a prompt. So you can see them on the left hand side here, they've loaded. So I can just check they're there. The first thing to do is to make the executable. That's done. And then to run it, I sometimes use the time command, but UFOLBM. And so that is running, and that's how quick it is to get a case running on Runpod. So that's running on a GPU. So the first thing it does is to do a flood fill of the live cells. So we've got 120 million cell mesh there, and 114 of those are live cells. So once it's done that, it starts iterating. So bearing in mind this is 120 million cell mesh, that's how fast it's iterating. It's just done 100 iterations already. I'm just going to basically leave that iterating for as long as is needed. I've set this one up to save a slice of data every 1,000 iterations. So basically you can just go away and you can let it finish. And then when it's done, all of your output files should be on the left here. So normally I would just sort of, while it's running, I would just have a look at the slice data just to check that the case is running as expected and that it looks okay. And that's about it. So the other thing you can do is you can go to pods and monitor the case. So if you have a look at the pod that you're running, you can see here that GPU is running at 100%. The GPU memory used is only 36%. So that is a 48 gigabytes of RAM on that particular GPU, and I'm only using 36% of it. And then this shows you the CPU and CPU memory usage. So that's quite useful. The GPU RAM used is probably the most useful one because you can check how close you are to the limit. And then in the top here it shows you your balance. So I've got $2 of balance at the moment, so I'm running a bit low, but you need to keep an eye on that because it will cut out if it gets too low. And so there we are. That has literally done 1,000 iterations. It's saved a VTK slice. Then that slice appears on the left here. So what I like to do, this is just a single slice, so I can then download that. Excuse me, it downloads really quickly, and then open it. So I open it from there, that'll just load into PowerView. And so it's showing the outline. So I just go to surface, and then I can go to velocity. So that is literally how fast it is to run something on Runpod. You can upload the files quickly, you can run it quickly, and then you can download the solutions quickly. I mean, this has only done 1,000 iterations, so it's not really, there's not much going on yet. But if you go to new T, you can see the viscosity field. I've just done a hack to put a bit more viscosity on the surface of the car here, so that's why that one looks a bit more noticeable, which is good. That's exactly what I wanted. And um, the other thing I can look at is LCD, which is your live cut cell and dead region. So you can see that's this Porsche car. That's what the mesh looks like around it. So yeah, you've got Newt, you've got Rho. You can see all the shock waves bouncing around because it's well, not shock waves, the pressure waves bouncing around because it's very early on in the flow solution, and those will soon dissipate, and the velocity there. So that is basically how you can run UFOLBM on Runpod.